Assalamualaikum, my name is Liyana Dhamirah binti Muhammad Imran and I am the group leader.
Assalamualaikum, my name is Iman binti Khairul Anuar.
Assalamualaikum, my name is Amirah Nadia binti Tukiman.
Firstly, I am going to present about the abstract of this study. In this study, Riccati Differential equations are solved numerically by two adaptive Riccati methods, which are Fehlberg method and Dormand-Prince method. Although in some previous study, it have been solved analytically and numerically by several methods. Then, relative error is used to determine the accuracy and efficiency of both methods. The result obtained shows that Dormand-Prince method is more accurate and efficient than Fehlberg method in solving Riccati differential equation. Further researchers can use different kind of adaptive Riccati methods and utilize transaction error to determine the accuracy and efficiency of these methods. Introduction. Riccati differential equation is one of the simplest and famous first-order nonlinear differential equation used in various fields of mathematics, physics, and engineering, and it can be solved analytically and numerically. In this study, Riccati differential equations are solved numerically by Fehlberg method and Dormand-Prince method. Since there are some differences in the working for each method, we want to find out which method is more accurate and efficient in solving Riccati differential equation. Therefore, three examples of Riccati differential equation are chosen from an article by Masjid Jami and Shaigan in order to determine the accuracy and efficiency of the proposed methods. Since the numerical method requires long calculation, MATLAB software is used. Problem statement. In previous studies, various types of Riccati differential equation have been solved by several methods, but it may have some disadvantages and restrictions. Other than that, there are limited studies in solving Riccati differential equation by adaptive Riccati methods. So, the first objective of this study is to solve the Riccati differential equation by Fehlberg method and Dormand-Prince method. Next, this study aims to determine the accuracy and efficiency for solving the Riccati differential equation by Fehlberg method and Dormand-Prince method based on the relative error. The scope of this study is to solve the Riccati differential equation by Fehlberg method and Dormand-Prince method. Three examples of Riccati differential equation were taken from a research article to test the accuracy and efficiency of the proposed method. The limitation of this study is that the software used is only focusing on MATLAB software, although numerous other numerical analysis software is available. The significance and benefit of study are to provide an effective approach in solving Riccati differential equation by two adaptive Riccati methods and to provide an insight for other researchers to apply the proposed method to the other first-order nonlinear equations. Now we move on to background theory. First, we are going to look at Riccati differential equation. Shown here is the form of Riccati differential equation where Px, Qx, and Rx are continuous functions of x. To find a solution, an interval will be divided into few equal subintervals with mesh length hash. Next, Fehlberg method. Fehlberg method is a single-step method used in solving initial value problem for ordinary differential equation that requires 6 function evaluation per step. The slide shows the formula of Fehlberg method and its 6 function evaluations. Dormand-Prince method is another method used in solving initial value problems for ordinary differential equation. It has 7 function evaluation per step but uses only 6 function evaluation to find a solution since it has first same as last property. Shown here is the formula of Dormand-Prince method and its function evaluations.
Next, the literature review for Riccati differential equation. This equation is named by D. Ellenberg, which written in the article by Krajko in 2005. Plus, there are other methods to apply to solve this equation, which are Edomier's asymptotic decomposition method and Edomian decomposition method, which written in the article by Beiser and Dittgar in 2015. Next, Fehlberg method was developed by the German mathematician Erwin Fehlberg. This method also a way to ensure the accuracy of an initial value problem in the solution by solving the problem twice, which are written in the article by Ahmad and Charan in 2016. Dormand-Prince method is the member of the ODE solver in Riccati family. This method is also used for chaos and chaotic systems, which found in article by Koyun Chu and Seeker in 2019. For methodology and implementation, the first step is we identify what are the problems that we want to solve in this project. Second, we tend to identify the method for solving this problem, which are Fehlberg and Dormand-Prince method. Next step is we use 3 examples that were taken from an article by Masjid Jameh and Shaigat in 2017 as for solving the problem using numerical method. As for the implementation part, we find y1 by letting I equal to 0 and using the initial condition as you can see in the first box, we compute the slope of k1. Then, we use the value of k1 to compute the slope of k2. Use value of k1 and k2 to compute the slope of k3 and so on. After that, we use all the slope values to approximate the y1. And then to find y2, we can let the I equal to 1, I equal to 3 to find y3 and so on. For step 4, we do the error comparison by using formula of relative error. And then the last step is we determine and compare the accuracy and efficiency of both methods by using the relative error.
There are 3 types of example discussed in result and discussions. For example 1, the result shows that values obtained for Dormand-Prince method close to exact solutions compared to Fehlberg method. From the figure that are computed from MATLAB software, the blue line represents Fehlberg method, the green line represents Dormand-Prince method, and the red line represents the exact solution. The figure also shows that the 3 lines seems to overlap with each other, as the difference in value produced by the 3 methods are very small. However, it is highly significant. In comparison with Fehlberg method, the results obtained by Dormand-Prince method are closer to the exact solutions. Now, let's take a look at results obtained for example 2. Based on the table and the figure, the result obtained in example 2 is similar to example 1, which values obtained for Dormand-Prince method close to exact solutions compared to Fehlberg method. It shows that the results obtained by Dormand-Prince method are closer with the exact solutions compared to Fehlberg method. Next, we are going to discuss the results obtained for example 3. Based on the table and the figure, the results obtained in example 3 is also similar to example 1 and 2, which values obtained for Dormand-Prince method close to exact solutions compared to Fehlberg method. In comparison with Fehlberg method, the results obtained by Dormand-Prince method are closer to the exact solutions. Now, we move on to the comparison of error. Based on the table, relative errors for Dormand-Prince method are very small compared to Fehlberg method at every point and example. This shows that Dormand-Prince method is very accurate in solving the Riccati differential equation. Therefore, it shows that Dormand-Prince method gives better approximation as it is more accurate and efficient than Fehlberg method. In conclusion, the objective to solve the Riccati differential equations by Fehlberg method and Dormand-Prince method is achieved, which solve 3 different types of examples. The second objective to determine the accuracy and efficiency for solving the Riccati differential equations by Fehlberg method and Dormand-Prince method is also achieved. The relative errors for all examples by using Dormand-Prince method are smaller compared to Fehlberg method. Therefore, the results obtained shows that Dormand-Prince method gives better approximation for solving Riccati differential equation as it is more accurate and efficient than Fehlberg method. In future researchers, it is recommended to use various numerical methods such as Kashkap and Bogaki-Champagne, which are also a part of adaptive Runge-Kutta method. Besides, the researchers might utilize the truncation error to determine the accuracy and efficiency of these adaptive Runge-Kutta methods.